All right. We are going to talk about the sum formula for a finite geometric sequence and how to use that. We've talked about in my previous tutorials on how to use the sum formula for a arithmetic sequence, but now we're looking at geometric. Once again, our geometric sequences are exponential, and that's going to be a key thing when we're going to be dealing with this. Now, to find the sum formula, because they're geometric, we're going to have this where we take our first term times 1 minus our ratio, whatever the constant multiplier is, to the n power over 1 minus the ratio. That is our equation that we're going to be using to find our sums. Okay? So you might want to take that, copy it down, all right, in your notes, because we're going to use that, all right, to identify the partial sums of these different geometric series. So first off, we have is we're going to find this one. We're going to find this sum going from term 1 to term 9. Okay, so we're going to find the first nine terms. We're going to add those together. And so we're going to take our first term. To figure out our first term, we're going to plug in the n value into there. And what we have is 1 minus 1, which is 0. So negative 2 to the 0 power is 1. Make sure you do that and you actually plug in the value into the function to find out what that first term is. Okay, because it changes, if you notice, in all of these different ones, so you want to make sure you do that. At times, it will not always equal 1, but many times it will. So a lot of students will get confused when it doesn't. So now we're going to go 1 minus, well, our ratio. Since it's exponential, our ratio is always the base, and so in this case, it's going to be negative 2. And we're going to raise that to the n power. Well, our n value, recall, just like with arithmetic, we find our n value by setting that, take the upper limit minus the lower, and we can just add 1 to that. Okay, so from here, we're going to have that, and we see that it's going to be 9 over 1 minus negative 2. Now, normally with exponentials, we would not have a negative base. However, since these are sequences, you can multiply things by negative numbers, so we will have a negative base in this case. All right, from here, we want to plug this into our calculator because it's a little complex when we do this. All right, and what we have right there, we take this out. And when we have that, I'm going to do both. So if I go second alpha here, I'm going to do the summation first, just to verify that this actually does work. You have to take my word for it. There are other tutorials that will share why this equation actually does work. And you can check those out, and I might make one on explaining that in just a little bit. But for right now, we are going to find what this sum is. All right, put in negative 2, raise that to the x minus 1 power, and we have that. Okay, press enter, and we have that 171. Now, if I go over here and I plug the other stuff in, so I have 1 minus, parentheses, negative 2 to the 9th power, and close the parentheses, and divide that by 1 plus, it appears to be 2, okay, because the negative is positive. And I just multiply this by 1, so I didn't put that in there. When I press enter, I get 171. So it happens to be correct that we get, in each case, the same answer. That's what we have. All right, well, let's try some more. All right, so this one, what we're looking for is, all right, our first term. So we plug this in here, we get 0. All right, so sum of the first, actually, 16 terms, because we're going from 0 to 16. Remember, n equals upper limit, 15, minus the lower limit, plus 1. So it'll be 16 terms. And we're going to be starting with our a sub 0 in this case, a sub 0, because that's our initial term. So we plug 0 in there. And 4/3 to the 0 power is 1. And then we have that multiplied by 2, so it's going to be 2. So this is different. We have 1 minus our ratio, which is 4/3, because that's our base. And we have the 16th power over 1 minus 4/3. All right. We can then put this in our calculator and identify this answer. So we go over here, say 2, parentheses. Make sure you do double parentheses. You have 1 minus 4/3, 4 divided by 3, to the 16th power. That's going to be really small. All right. And then we're going to divide that by, put parentheses around that, 1 minus 4/3. And that is okay. We can just go like so. And we get an answer of, oh, decimal. All right. 592.647, and we have that as our answer. To verify that works out, or the other one, we can go second set, get our simulation notation, and just determine if this is going to be the same thing. From x goes to 0, into 15, and we can plug in 2 times 4 thirds. Close that, and raise that to the x power, and do that. And we get the same thing. All right. This next one we're going to do is we're going to take this. Well, we're going to do one more, which is set this one up and see how this goes. All right, so what we have right here is we're going to find the sum of the first 7 values. All right, and we're going to first find our first term. In this case, we're going to plug in 1, and we get 1 minus 1, which is 0, times 64, so our first term is 64 in this case. We then have 1 minus our ratio. Our ratio is -1/2, and we're going to take that to the 7th power, and all over 1 minus our ratio, which is -1/2, and there we have it. That would be our way of setting it up, and you can go to your calculator to figure out the answer, but we've done that several times already, and I'm sure you can do it, but just want to set that up for you, and that's how you can find the partial sums of geometric series, okay, using the formula which we had before. So this sum formula is the first term times 1 minus the ratio to the n power over 1 minus r, the ratio. All right, so good luck and God bless on the rest of your assignments.